All right, so we kind of went over in our lesson today. We went through the worksheet that we did earlier that had monoatomic ions, which the ion sheet that I gave you for reference, those are the ones like on the top half that, you know, they consist of only one type of atom. So if you look at the bottom of that sheet, you actually have ions that are made of more than one atom bonded together covalently, but that form collectively a charged ion. Okay, so that's what poly just means many. So we're talking about ions that are formed from several atoms bonded together. So I'm going to go through some examples today, and I'm going to talk about how they're the same as monoatomic ions in their behavior, but also how they're different, okay? So let me write a couple of examples here really quick. So let's say that I'm going to combine lithium, which is a monoatomic ion, with nitrate, which, as you can see by the formula, consists of 1 nitrogen and 3 oxygen atoms bonded together, but they have a negative charge. We still would say, you know, if we have this +1, how many of these -1s do we need in order to achieve an overall charge of 0? And this is pretty simple. They're just going to combine in a 1-to-1 ratio. And I would say be careful, don't get confused and make this more difficult than it is. So the charges go away. These stay together, right, as a unit, NO3. So in this way, it's exactly like combining those monoatomic ions that we've talked about. Let me give you another scenario, however. Now we have to be a little careful. Remember, we can use the crossover method. That's totally fine. And we can put this 2 down here. And then the 1 goes down here, but I don't have to write the 1. I'm going to write it here, but in my final formula, I actually am not going to write that. So here's the problem, and here's how it is different. It looks like I have MgNO3, 2. It looks like I have NO32, and that's not what I have. So I have to do something special with polyatomic ions that I did not have to do with monoatomic ions, and that is I have to put parentheses around my NO3. Because what I'm really saying is I want 2 of this whole unit, this polyatomic ion. So this formula, NO3, has to stay the same. I can't change anything about this formula except I'm going to get rid of the charge. So I put NO3 in parentheses, and I put a 2 on the outside. So it is 1 magnesium and 2 of the nitrate ion. So let's do a couple more examples. All right, let's look at this one. Aluminum with a +3 and the carbonate ion with a -2. So I'm going to use my crossover method. Put my little 3 down here. Sorry, I'm writing with my mouse, so it's really worse, even worse than my normal writing, which is pretty terrible. So, all right, so here's my final formula. Okay, so my formula here, Al2CO3, 3. I know that I need parentheses here because I have 3 of these carbonates. Remember when we count atoms, just a quick reminder, we use this like the distributive property in math. So this really does mean I have 3 carbon and 3 times 3, or 9 oxygen, and then 2 aluminum. We'll work on balancing equation stuff later, but just know that that's what that formula means. Sometimes students kind of want to do one of these where they're like, oh, I have 2 of this. Maybe I need parentheses around this. Well, we don't put parentheses around things that are only one atom. So we definitely don't need parentheses around that. And you can't just put parentheses where you don't need them. It's wrong. So we can only use parentheses with the polyatomic ion, never with the monoatomic ion. Let's do another example here real quick. What if I do potassium, which is a +1, carbonate, which is a 2-. Again, I love the quick, easy method, so I'm going to do the crossover method. This is going to be a 2. It's my final formula. Do I need parentheses in this formula anywhere? I do have a polyatomic ion here, but I only have one of them, so I do not need parentheses here. And in fact, if you put parentheses, it is wrong. If you put parentheses and there's no little subscript outside of this parenthesis, it's wrong. You can't just say, well, it doesn't hurt anything, but we can't just willy-nilly put parentheses just because we like them. So this would be the correct way to do that. All right, so I've given you some practice problems to work through. Have them done maybe tomorrow when you come to homeroom. Maybe we can go through those, and I'll take any questions you have at that time. Thank you.